Here we are on page 13 and 14. They're giving us a variety of problems here, so you're going to recognize these problems from the last few days. They're obviously a little bit more challenging when you don't know what's coming. Find the equation of a tangent to the curve y equals x minus 4 quantity squared at the point where x equals 5. Okay, so there's a couple ways to do this. One is you could do, you can multiply it out, use FOIL and multiply it out, and then take the derivative, and then substitute x equals 5. So the way you would do that is you would say y equals the first term squared, the last term squared, the outside and inside, and that multiplied together, that will give you that. Okay, so if you take the derivative of this, it's going to be 2x minus 8, and this would go to 0, right? And then you would substitute in x equals 5. And when you do that, you would get 2 times 5 minus 8, which is 10 minus 8, which is 2. Okay, so the equation of the tangent to the curve would be 2, because, as we know, the tangent to the curve has the same gradient as the curve at that point. So that's why the tangent to the curve has gradient 2. Okay? The way you would do that with the calculator is you would simply draw the tangent line. Maybe that's a lot easier because you don't have to do FOIL or anything like that. You could do x minus 4 quantity squared, and then you graph it, and then you would find the tangent, and we know we do that with second draw, tangent number 5, and then we just enter x equals 5, and then it will draw the tangent line at x equals 5, and it will give us the formula for the tangent line, y equals 2x minus 9. So if we know that the tangent equation is 2x minus 9, then we know that the 2 here is the gradient. Okay? There we go. So either way is fine. Next one. Find the equation of the normal to the curve y equals x plus 6 over x at the point where x equals 4. Okay, so remember, to find the normal, first thing we want to do is find the gradient of the curve. Then we're going to take the negative inverse to find the gradient of the normal. And then we are going to find a second point. And then we are going to do ln-reg and draw a line through those 2 points. Okay, so first we're going to do y equals, and then we're going to put in the equation, which is x plus 6 over x, x plus, we'll put parentheses around it just to be safe. Oops. It actually, using PEMDAS, we don't need this, but if you're not comfortable with PEMDAS, go ahead and put parentheses where whenever you have a horizontal bar for the fraction. And then we're going to graph it. We're going to get this kind of strange curve, and then we are going to find the gradient at x equals 4. And the way we do that is we could do second draw tangent, and then take the gradient from the equation of the line, or we could do second calc and do dy dx and say 5, and that would give us the dy dx is 0.7599999. So let's say it's 0.76. Okay, so the gradient is 0.76. Now what's the negative inverse of the gradient? Okay, so we'll do negative 1 divided by 0.76. See what we get? Negative 1.32. Now, to draw our sketch to figure out what the equation for the normal line is going to be, we have to know the exact coordinates of this first point. And we do know that the x is equal to 4, right? The x value is 4. We don't know the y value yet. To find the y value, we can substitute it into the equation here. So that would be 4 plus 6 over 4, which is equal to 4 plus 1.5, which is equal to 5.5. So the y coordinate here is 5.5. And then what happens when you go to the right of this line? What does the slope tell us it's going to do? The slope is going to be negative 1.32. So the rise is going to be negative, so it's going to go down, negative 1.32. And then it's going to go run 1. Okay? So the triangle that this graph is going to make is going to look like this. And what I'm going to do is I'm going to move this up here, so that we can draw this little triangle. Okay? So this point is 4, 5.5. And we're going to go down 1, and we're going to go down negative 1.32, and then we're going to go over 1. So the new point is going to be, let's see, 4 minus 1.32 would be something like 3.68. 3.68, comma, 6.5. So the second point would be 3.68, 6.5. Now we have 2 points. We have this one and this one. I'm going to put it in the calculator in stat edit. Let's see, clear. Well, I'll just go up here. Clear, clear, clear. Okay, and we're going to put 4 and 3.68. And it's going to be 5.5 and 6.5. Does that make sense? Okay, and then we're going to do stat calc lin reg for L1, L2. Frequency less should be 0 or nothing, and that is our equation. Okay, so we have the equation is for the normal curve is y equals negative 3.125 x plus 18. Okay, now the other way to do that would be with algebra and taking the derivative or using point slope form. Okay, so if you're comfortable with that, go ahead and do it that way. Find the equations of the tangents to the curve y equals 3x squared minus 2x at the point where y equals 8. Okay, so this should be an easy one, right? Because it's asking for the tangents to this curve at the points where y equals 8. So the hard thing about this is they didn't give us x, they gave us y. It's easy to find the tangent when they give us x, but what about when they give us y? Well, first thing you're going to do, since they gave you an equation, is always to graph it. So let's do that first. 3x squared minus 2x. 2x. 3x squared minus 2x. Second insert. 3x squared minus 2x. Okay, and then we'll take a look at when is y equals 8 in this graph? Well, if we look at the table, we can figure that out, right? So, let's see. There's one, 2, 8. So one of the points is 2, 8. Where else? Is there any other place where it's equal to 8? Looks like it's 8 between 5 and 16 here. What if we increase the step size? Plus 0.5. Is that enough? No, it's not. What if we increase even more? We'll go to here and we'll go plus 0.1. Looks like if we step by 0.33, that may be the magic number. Plus 0.33333333. Now where are we? there it is, negative 1.3333, comma, 8. So those are the 2 points. Find the equations of the tangents of the curve. Okay, so now we just need to put x equals 2 and x equals negative 1.33 in for the tangent. Remember what the graph looks like. It looks like that. So we're just going to do second draw 2 times. First time we do it, we're going to put in tangent, and then we're going to put 2. And then our equation of the tangent line is going to be y equals 10x minus 12. And then we're going to do it again, second draw, tangent, and then we're going to put negative 1.33, negative 1.333. And then we'll get another tangent, and it'll be, the equation is y equals negative 9.999998. So that would be, that's basically negative 10, right? Negative 10x minus 5.33. Okay? So, a little challenging because they gave us the y instead of the x. So it was, we had to use table to find out what the x would be at that point. Okay, number 7. Find the equation of the normal to the curve 7 minus 5x minus 2x cubed at the point where it intersects the x-axis. So we just put it in the calculator. We're going to graph it. Okay, so it says where it crosses the x-axis, we're going to find the normal curve. So to find the point we want, we need to figure out when what point this is. Maybe we could use trace this time. Let's see. Trace. Let's see if we get to where it crosses the x-axis. We went past it. Okay, not so easy. Let's do the table, see if we can find it through that method. Okay. Oh, we got it on set to step size 0.33. Why don't we set it back to step size of 1. Step size 1. Okay. And then let's see, where it crosses the x-axis. Oh, look, 1, 0 is the point where it crosses the x-axis. So the point is 1, 0. Now it just becomes exactly like the problems we've solved before with normal. So the first thing we're going to do is we're going to find the gradient. Then we're going to take the negative inverse. Then we're going to find a second point. And then we're going to do ln/reg through both points. Okay, those are the 4 steps. So first we're going to find the gradient. We can do that, and the gradient we're going to find at 1, 0. We can use the tangent function, or we could do second calc dy dx, and we are going to put in x equals 1, and that gives us the dy dx is negative 11. And then the negative inverse of negative 11 will be negative 1 over negative 11, which is equal to 1 over 11. So that is the slope of the normal. Okay? And then now that we have the slope of the normal, the only thing we need to do is find a second point. So the first point is 1, 0. And the next point, let's see, the rise over the run is going to be, it's going to be a rise of 1. That's the rise. And the run is positive 11. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the run, and 1 for the rise. So the line would be between 1, 0 and, let's see, 11. So that'd be 12, comma, and this is 1. So that would be 12, 1. Okay? So those would be the 2 points. We just found the second point. So the second point is 12, 1. And the first point is 1, 0. And now we're going to draw a line through those 2 points by using the ln/reg function. So we go here and we say 12, 1 and 1, 0. 12, 1, 1, 0. And then we do stat, calc, linreg, L1, L2, blank, calculate. Okay, so our function is y equals 0.0909, and actually we already know that the slope is 1 over 11, right? 1 over 11 times x minus 0.0909. And actually you can see that 0.0909 is actually equal to 1 over 11. So we could write y equals 1 over 1 over 11 x minus 1 over 11. Okay. Find the value of x for which the gradient of the tangent to the curve y equals 4x minus 3 quantity squared is 0. Actually what they're saying is when is the gradient of this function equal to 0? We might be able to see that just by graphing it, and it's because they asked us such an easy point. They asked us to find when the gradient is 0. If they'd asked us another one, then we wouldn't be able to see by eyeballing it. But I'm going to show you why. If they ask you for when the gradient is 0, it might not be too hard. It's a parabola, right? And if I draw the parabola here, when is the gradient of the parabola 0? Well, remember, gradient of 0 is a flat line. So when would you put a mosaic tile on this that would be a flat line? It would be right here at the vertex. Okay, so where is the vertex of this parabola? Well, maybe we can see it by second table. It might be around 1. It might be around 1. Okay. Let's see if we can adjust the step size to find it. We'll do plus 0.1. Now, does that help? See, there it is. It's at 0.75 probably. Let's increase the step size to 0.05. There we go. There we go. See, the vertex is at 0.75 comma 0. Okay, so when you have the vertex of a parabola, the gradient is going to be 0. The other way you could do this is you could find the gradient of the function, or the derivative of the function. And to find the derivative of the function, remember you have to do FOIL because we don't know how to take the derivative of this. So we would say 4x quantity squared, and then the L would be plus 9, and then the outside inside would be negative 24x. And if we took the derivative of this actually is it's equal to 16x squared, right? If we took the derivative of that, it would be 32x minus 24. Okay? And so if we graph this and found out when this is equal to 0, we would find out that actually it's equal to that. And I'm just going to show you how to do that because we did problems like this too before. Remember we put y1, we put the function, and y2 we put the gradient minus 24. Graph. Okay, and then we say second table. And then when does the gradient equal 0? It equals 0 at x equals 0.5. Okay? So what is the equation of the tangent at this point? Well, the slope of the tangent is equal to 0, right? So it's y equals 0x, and then the y-intercept is just 0. So y equals 0. Okay? All right. 11. Find the value for x for which the gradient of the tangent to the curve y equals x squared divided by 2 plus x minus 3 is 5. Okay, so we're going to do the same thing again. We are going to find the derivative, and that's going to be the gradient. So the gradient is it's going to be 2x divided by 2 plus 1. That's the gradient, okay? So 2x divided by 2 is equal to x plus 1, okay? And we're going to see when is that equal to 5. So we're going to put both of these functions here. The first function is going to be x squared divided by 2 plus x minus 3. Okay. X squared plus x. So I have the function here, and then I have the gradient here, and then I'm going to look at the table. Actually, I just accidentally did the graph. I'm going to look at the table. And I want to know when the gradient is equal to 5. So that's when y2 equals to 5. Actually, I can change the step size back to what it was before, to 1 or whatever. I'll do that in a minute. So when is it equal to 5? Okay, there we found it. At 4. So the gradient is equal to 5 at x equals 4. Okay, and what would be the point on the graph? It would be 4, 9. So the ordered pair would be 4, 9. That's when the gradient is 5. Okay, and let's see, what is the equation of the tangent at this point? Then we can use second draw tangent, and we're going to do it for this function, right? And we're going to just say at x equals 4. There it is. And the equation is y equals 5x minus 11. Okay. Number 13. Okay, find the value of x for which the gradient of the tangent to the curve is 4x plus 3 over x to the fourth is 16. Find the equation of the tangent, find the equation of the normal. Okay, so let's put both the equation and its gradient function, or the derivative, in the calculator. It would be 4 plus 3 times negative 4 times x to the negative fifth. So that's equal to 4 minus 12x to the minus fifth. And so I'm going to put these two in the calculator. You can see I've finished that. And then I'm going to graph it. So one of these is the function, and the one is the gradient function. Now we want to know when the gradient is 16. So we look at the table. And oops, let me change the step size back to 1 here. So I do plus 1. I make sure that I'm on an integer when I do that, otherwise it gets really screwed up. Okay, and it got kind of screwed up anyway. Okay, so if I look at, let's see, when does this equal to 16? So I'm just going to kind of move over here until it gets to 16. Doesn't look like it's going to get to 16 this way. I'm looking right at here, okay, at the y2, which is the gradient. So when does the gradient become 16? Well, it must be like very close to 1. I mean, it must be like inside, close to 0. Okay, so you see, like when I get far away from 0, it just gets close to 4. It's an asymptote. Ah, there we go. There it is. At negative 1. So x equals negative 1. So x equals negative 1, y equals negative 1. So the point that we're interested in that has a tangent gradient of 16 is negative 1 comma negative 1. So what's the equation of a tangent at the point negative 1? So we're going to graph it, and then we're going to draw the tangent. Second tangent 5. And are we interested in this function here? 4x plus 3. Yes, we are. Okay, sorry, calculator mishap there, but this is the equation, or this is the function. And now I'm going to find the equation of the tangent at this point, -1, -1. So we do second, draw, tangent 5, and then at point -1, enter. Okay, there is the function, and the equation of the tangent is going to be y equals 16x plus 15. And then C asks the equation of the normal line. And remember, to find the normal line, it's kind of a tedious process. We need to find the gradient. Then we find the negative inverse. And then we find a second point. And then we do ln reg. So the gradient we already know because it's right there. The gradient of the tangent line is 16. The negative inverse would be -1 over 16. The second point we will find by drawing a sketch. So the first point is -1, -1. -1, -1. And then I'm going to draw a rise over run, where the rise is -1, so we go down, and the run is +16, so we go 16 units to the right. And then that would be this triangle. And so that would be, let's see, we started out at -1, so if we go one more down, if we go one more down, it would be -2, the y. And the x would be plus 16, so that would be -1 plus 16, it would be 15. So our second point is 15, -2. First point is -1, -1. And if we put these into stat edit, we'll get the equation for the line. So we'll get -1, -1, 15, and -1. I'm sorry, not -1. Yeah, -1. And the next one is -2. Okay, and then we do stat, calc, ln reg, L1, L2, calculate, and then we get y equals -0.0625. That's the same thing as -1 over 16, I believe. And b is -1.0625. Okay? All right. Wow, look at all these. Okay, number 17. The gradient of the tangent to the curve y equals kx squared minus 2x plus 3 at the point 4, comma, b is 2. Find the value of k and that of b. Okay, so the gradient function is 2kx minus 2. Okay, because we took the derivative of this and we took the derivative of that, and the derivative of 3 is 0. Okay, so we know that the gradient function when x equals 4, do you see x equals 4, is 2. So we're gonna substitute we're gonna substitute 4 in for x minus 2 equals 2. Okay, so that is equal to 8k minus 2 equals 2. So that means 8k is equal to, add 2 to both sides, we get 4. So k is equal to 1/2. Okay, so find the value of k. We just found the value of k. What's the value of b? Okay, well now we know that the function is y equals 1/2 x squared minus 2x plus 3. And we would like to see what this is equal to when x equals 4. So we're going to substitute x equals 4. 4 squared minus 2 times 4 plus 3 equals. Okay, so we're going to have 16 divided by 2 is 8. Minus 8 is 0 plus 3. 3. Okay, so y equals 3. Actually, not y equals 3, b equals 3. Okay, so that's going to be 3.